Hi everyone, my name is Lydia, and this is what I wish they taught me about econometrics and introduction. Let's do a quick recap of all the assumptions and the statistical properties we've seen so far, because we're about to add one more final assumptions to the list today. So far, we've seen the first 6 assumptions. Under the first 5 assumptions, we had that OLS was unbiased, and then under the addition of the homoscedasticity assumption, we were able to get an actual formula for the variance of the beta j hat. We also found an unbiased estimate of the sigma square, and we were able to say that the OLS is the blue estimator with the lowest variance, meaning the best linear unbiased estimator. So for some of you, a follow-up question that might come up is, what about the distribution of the beta hat? And the thing is, under these assumptions 1 to 6, we actually don't know much about the distribution of the beta j hat. And for those of you who didn't have this follow-up question, it's completely fine, but there is a reason why you should worry about the distribution of the beta hat, and a reason why you will have to think quite a bit about the distribution of the beta j going forward. And the reason for it is that we cannot do inferences otherwise. So I've mentioned quite a bit, and you have probably seen in your lectures as well, that you do a lot of hypothesis testing, guessing confidence intervals or predicting confidence intervals. And the thing is, without you having certain assumptions on the distribution of the beta hat j, you can't rely on the answers for whatever results you're getting. Which brings us to the last assumption that we're going to add to the list of the OLS assumptions, and that is assumption 7, which tells us the error terms distribute normally and independently from each other. And some of you might have seen the mathematical expression for it. If you are wondering what this squiggly sign is here, it's just a very squiggly n to mean that I am referring to the normal distribution. The mean here is 0, and this is the variance for the distribution. Now that you have this, you might question, but we know that we don't observe the error term, so how can we be sure it's normally distributed under these parameters? And the answer to that is this assumption is unlikely to be true, actually. Since it's a strong assumption. However, it doesn't matter. If n is large. And I'm going to put in brackets here as CLT, which means central limit theorem. So by using the central limit theorem and the law of large numbers, we can say that even if we don't know exactly what the distribution of the error term is, if the sample is large enough, this n is sample size. So if the sample is large enough, meaning as n goes to infinity, then we can assume that the error terms distribute approximately normally. With this, we have finished all of the assumptions. Now there are consequences if we add assumption 7 into the mix, and we'll see those in the next video.